Hi guys, today we are going to do converse of midpoint theorem. In the last lesson we have done midpoint theorem. So the converse of midpoint theorem is the line segment drawn from the midpoint of one side of a triangle parallel to another side bisect the third side of the triangle. So we will do it today. I'll prove the converse of midpoint theorem today. So let's go once again. The line segment, the important part I am marking with the red marker, drawn from the midpoint of one side of a triangle parallel to another side bisects the third side of the triangle. We need to prove that. So for this we need one triangle. After reading all the datas, we need a triangle. We need a triangle, any triangle like before. We name it A, B, C. And what the question says, the line segment drawn from the midpoint of one side of triangle. So let's take that one side as AB and mark this point as midpoint and we make it D. And the line segment drawn from this midpoint is parallel to another side. Let's take another side as BC. So you have to draw a line which is parallel to BC and which is meeting AC at any point. You can give it the name, any point means E. So what is in the constructions? ABC is a triangle, D is the midpoint of AB, and the line drawn from the point D, the midpoint, is parallel to BC, and this line produced from D is meeting the side AC at any point E. So we have to write given. Given. What is given? A, B, C is a triangle. ABC is a triangle in which D is the midpoint. D is the midpoint of AB. That is, if D is the midpoint of AB, then what we can write? AD is equal to DB. These sides equal. And what more is given here? And what more is given? DE is parallel to BC. This is all given in the diagram. So what we have to prove now? To prove according to the question, what you have to prove? Bisect the third side. What bisect the third side? The line segment drawn from the midpoint, this DE. Bisect the third side means this DE divides AC into two equal parts, AE and EC. So we have to prove AE is equal to EC. So in order to prove this, we did some more constructions here. Okay, let's go to the constructions like before. From this point C, we have to draw a line parallel to AB. Okay, draw a line parallel to AB and produce this DE. So that this line meets this parallel line, name it any name, suppose N, at F, meets here at F. So what we have done in the constructions, we have to write here constructions. In constructions, what we have done? From the point C, we have drawn line CM parallel to AB, and we have produced this D to meet at F. So we can write constructions. CM parallel to AB is drawn, and DE is produced. D is produced to meet CM at point, where it is meeting at point F. This is the constructions. Now we can start the proof. Before we start proving, now see this quadrilateral DBCF. What you can say here? In quadrilateral. In quadrilateral DBCF. In quadrilateral DBCF, what are the properties here now? Now, according to the questions, we have drawn DE parallel to BC. So, if D is parallel to BC, then definitely DF will be parallel to BC, because DF is the extended part of DE. So, what we can write here? DF is parallel to BC. Reason? Since DF is the extended part of DE, DF is parallel to BC. Okay. Another one here, we can write this DB is parallel to FC. Why? Because this, according to construction, this CM is parallel to AB. So DB is the part of AB as well as FC is the part of MC. So we can write here DB is parallel to FC. How we get this? By construction. Now, what is the properties of quadrilateral? If the two pair of opposite sides are parallel, then the quadrilateral is a parallelogram. So here, this is parallel to this and this is parallel to this. So this quadrilateral, we can say this is a parallelogram. Therefore, DBCF is a parallelogram. Parallelogram. Reason? Since opposite side, these opposite sides are parallel, DF parallel to BC and DB parallel to FC. So these are the opposite sides of a parallelogram. So if DBC is a parallelogram, then we can say that opposite sides of a parallelogram are also equal. So therefore, what you can write? DB is equal to FC. The reason? Opposite sides of a parallelogram. Opposite sides of parallelogram. So DB is equal to FC. So now DB, according to given, see what is given here? In it. Here, DB means AD. So in place of DB we can write AD. So therefore AD equals to FC. Since AD is equal to DB, it's already given here. Okay, now we have to take two triangles to make it congruent. So take triangle. In triangle, this one AED. In triangle AED and triangle, this one triangle FEC. Triangle FEC. Now this angle and this angle are vertically opposite angle. So you can write angle AED. Angle AED equals this angle FEC. Angle FEC. Reason is like before, vertically opposite angles. Another one. Again, this CM is parallel to AB and AC is treated as transversal. Then you can say that this angle and this angle are interior alternate angles and they are equal. So the name of the angle DAE. Angle DAE equals to, and this angle ECF. Angle ECF. Reason? Alternate angles. Alternate ANGLES angles. Why alternate angles? In CM is parallel to AB and AC is the transversal. AC is transversal. Okay. Then now another pair of side. This one AD is equal to FC. We already proved here. AD is equal to FC. Already proved. We have proved here. So These two triangles, according to these properties, angle side, these two triangles are congruent. Now you can write triangle AED is congruent to triangle FEC. So if these two triangles are congruent, then their corresponding parts are always equal. So the corresponding part of AE is EC. So we can write AE is equal to EC. Reason, corresponding parts of congruent triangles are congruent. So we need to prove this AE is equal to EC. So QED. Proved. So my friends, we proved today converse of midpoint theorem. That's all, and we come with another theorem next day. Thank you very much.